Hello everyone. As part of class 10 chapter wise series, today we will start chapter 2 Polynomials. We have already covered chapter 1. Do check it out. The link is in the description. Let's start. Before we start the portion for class 10, let's recall what we have learned in class 9. We begin with polynomial. So what is a polynomial? Polynomial is any algebraic expression in which the power of the variable must be a whole number. So first of all, what is an algebraic expression? Any expression that has constants and variables. Any expression with constants and variables is an algebraic expression. Now if in such expression if the power of the variable is a whole number. What are whole number? Whole numbers are set of numbers 0, 1, 2 and so on. So if the powers are whole numbers, that expression is called a polynomial. Generally, a polynomial is represented as p of x, where x is the variable and p is the name of the polynomial. Let us see some examples. Here q of y is a polynomial. First, are the powers whole number? The powers of the whole variables are whole numbers. And here the variable of this polynomial is y and the name of this polynomial is q. T of x. Here the variable is x, the name of the polynomial is t. P of u. The name of the polynomial is p and the variables in this expression are u. Again, is it a polynomial? See the powers of the variable, they are all whole numbers. So this is also a polynomial. But some expressions like 1 over x minus 1. Here, if I try to take this variable in the numerator, the power will not remain as a whole number. Here, root of x plus 2. Now, what is root of x? The power of x is x power half. We have studied this in ninth grade. So here, the power is not a whole number. So this is not a polynomial. Again, the variables are in denominator and if we try to take it in the numerator, they will become negative. X plus 1 over x. Now, in this case, the variable x is in the denominator. If I try to move it in the numerator, using the laws of exponents, it will become x to the power of minus 1. So, because of this term, even this expression x plus 1 by x is not a polynomial. It is also defined as expression with one or more terms with a non-zero coefficient. Since you people have already studied this chapter in grade 9, let us understand some of the basic terminology. So, first we will try to understand what is the meaning of terms of a polynomial. The parts of the expression that are generally separated by plus or minus sign, each such part is called a term of a polynomial. For example, in this example, 2x square plus 5x plus 4. The part of the expressions which are separated by plus or minus sign. Individually, each part is called as a term. So here there are three terms in this particular polynomial. Consider another example. For example, if I see the polynomial p of u. In this case, we see there is 1, 2, 3 and 4. How many terms are there? There are 4 terms which are there in this polynomial. Let us move on. The next term is a coefficient of a polynomial. Now, what is a coefficient? A numerical or a constant factor that is multiplied to a variable of a single term of a polynomial. So in short, coefficient is a numerical factor of every term. For example, in the term 7x, the numerical coefficient is 7. In this expression 3x minus y, for the term 3x, the numerical factor is 3. So the coefficient of x in 3x is 3. Consider this polynomial. Here we are having 3 terms. The coefficient of x square is 2. The coefficient of x here is minus 1 because minus x is nothing but minus 1 times x. So what is the numeric factor here? It is minus 1. So the coefficient of x is minus 1 and the constant term is 4. Let's move on. Degree of a polynomial. Now each term has some power on the variable. Degree of a polynomial is the highest or the greatest power of the variables in a polynomial. There can be more than one term in a polynomial and each term will have some power. So here the power of the variable is 2, here the power of the variable is 1, here the power of the variable in a constant term is 0. So for all the three terms, the highest power is 2. So for this entire polynomial, the degree of the expression is 2. Consider this example x power 4 minus x square plus 5x minus 7. The power of variable in the first term is 4, in the second term is 2, in the third term it is 1, the fourth term there is no variable so the power is 0. Of all the 4 terms, the highest power is 4, so the degree of this polynomial is 4. Very important to note, For a constant term, if there is no variable to it, its degree is considered always 0. Very important to note. Let us further move on. Next is a 0 or a root of a polynomial. The zeros of a polynomial are all those x values that make the polynomial equal to 0. What do we mean by that? For example, consider this polynomial x plus 4. Now, what value of x will make this polynomial's value equal to 0? So, that is minus 4, because minus 4 plus 4 will make it 0. So, minus 4 will be called as the root or the 0 of this polynomial. So, let us see again. All those x values that make a polynomial equal to 0 are called its 0 or root. How do I calculate the 0 of a polynomial? We can calculate the 0 of a polynomial by equating the polynomial to 0. For example, the same example, if I want to find out the 0 of this polynomial, I'll put it equal to 0. When I solve it for x, the value which I get, this value is nothing but the 0 or the root of this polynomial. I hope you have understood so far. Now we move on to the concept which we require for class 10. Now we will see the types of a polynomial based on its degree. We start with a linear polynomial. So a polynomial with degree 1 is called as a linear polynomial. What is degree? The highest power of a variable in a polynomial. So if we see the examples, all these examples, the highest power of the variable is 1. So all these are examples of linear polynomial. How a linear polynomial can be expressed in a general form? So it can be written as ax plus b, where x is the variable and a and b are the real numbers. For instance, we can see in these examples, the coefficient of x is a and the constant term is b. For example, in this particular case, we can say the coefficient of x, which is 3. So the value of a is 3, and the constant term, which is minus 5, it is the value of the variable b. So ax plus b is the standard form of the linear polynomial. Here, a is not equal to 0, because if a becomes 0, then the x term also becomes 0. And then it is no more linear. Now, every linear polynomial can have only one zero or root, which means it can have only one value of x that can make the value of the polynomial equal to 0. Now, for general form ax plus b, if we equate it to 0, we get the value of its 0 as minus b by a. How do we get this? We get this by solving this value. For x, we get ax as minus b, and from here x is equal to minus b by a. Now, all polynomials can also be represented as graphs. Also, we must note that since a linear polynomial has only one zero, its root will intersect the x-axis at exactly one point. Let us understand what we mean by that. Now, consider a linear polynomial y is equal to 2x minus 3. While plotting a graph, we need both x and y values. So, for plotting the graph, we take px is equal to y. So, now we will plot the graph for y is equal to 2x minus 3. We find 2 points by substituting different values for x and calculating the corresponding y values. Let us see how. Now, what we have done? First, we have substituted x is equal to 0. So, when x is put 0, we get y is equal to minus 3. So this 0 comma minus 3 becomes my first coordinate. To get the second point, we put y is equal to 0. So on solving that, we get the value of x as 3 by 2. This becomes the second coordinate. Now let us see how we will put it on the graph. This is the Cartesian plane. On this, we first plot the points. This point is 0 comma minus 3 and this is 3 by 2 comma 0. Now, if we join them together, we get a straight line for the polynomial y is equal to 2x minus 3. Now, since it represents a linear polynomial, we can see it intersects the x-axis at exactly one point. I hope all this about linear polynomial is understood, and now we can move further. Now we move on to the next polynomial, which is a quadratic polynomial. So any polynomial of degree 2 is called as a quadratic polynomial. Let's see some examples. In these examples, we can see the highest power of the variables is 2. Here, the degree of the polynomial is 2. These are some examples of quadratic polynomial. Now, just as we have learned about the standard form of linear polynomial, standard form of quadratic polynomial is given by ax squared plus bx plus c. Here, a, b, c are real numbers and x is the variable, and a very important condition, a is not equal to 0. Why we can't have a equal to 0? Because if we put a as 0, this x square term will not be there and then it will not be a quadratic polynomial. Also, we saw that a linear polynomial can have one root or one zero. A quadratic polynomial, since it has degree 2, it can have at most two zeros. Now here, see this term at most. It's a very important term, and what does it mean? We will find it out soon. Also, like a linear polynomial, as it has a linear graph, we can also draw the graph of quadratic polynomial. And when the corresponding x and y's are plotted for a quadratic polynomial, we get a U-shaped curve which is called a parabola. So, if I get a graph like this or a graph like this, these represent graphs for quadratic polynomial. Now this understanding of graph of a quadratic polynomial is very important because it enables us to find the zeros of the quadratic polynomial. So if I can locate the x coordinates of the point where the parabola is intersecting the x-axis, those points represent the zeros or the roots of the polynomial. How? Let us see. First of all, let us understand what all different cases or different types of graphs possible for a quadratic polynomial. Now the case 1, if I look it into the graph, I can get my parabola graph like this or like this. This is called as upward opening graph, or it is called as upward opening parabola. This is called as downward opening parabola. When do I get an upward opening parabola? When my coefficient of x square, that is a, if a is greater than 0 or is positive, in that case we always get a upward opening parabola. If a is less than 0 or is negative, we get a downward opening parabola. In this kind of parabola, as you can see, the graph is cutting the x-axis at 2 points. So here we can say for this particular polynomial, we will get two different roots. Likewise, here we will get two different roots. Now, if we assume that the graph is cutting the x-axis at, let's say, point A and A dash, the x coordinates of the points A and A dash will be the zeros of this quadratic polynomial. Assuming this as A and A dash, so for this particular downward opening parabola, the x values, let us assume that this point is minus 1 0 and this point is 1 comma 0. So we can say that for this downward opening parabola, the zeros will be minus 1 and 1. Now we move on to case 2. That is, here we assume that the graph cuts the x-axis at exactly 1 point. How do I draw the graph in this case? So this is how the graph looks like. It is either like this or like this. So what is happening here? It is just touching the graph. It is just coinciding with the x-axis at only one point. So what is happening? The A and A dash from the previous case, they are coinciding at a point A. So this particular case, when the graph touches the x-axis at exactly one point, we get only 1 0 for the quadratic polynomial. Again, for this, assuming that the coordinate is minus 2 comma 0, where the graph is touching the x-axis. So the root or the only 0 for this quadratic polynomial will be minus 2. What can be the third case? The third case is when the graphs do not touch the x-axis. Now, why is it happening? Because in this case, we may not have any real roots for the quadratic polynomial. It is not necessary that every quadratic polynomial must have a real root. If it is not having a real 0, in that case, the quadratic polynomial's graph does not touch the root. We say it has no real root. Real root means no real number value is satisfying the quadratic polynomial. Therefore, in that case, we say it has no 0. So, we saw three cases where the graph was touching the x-axis at two different points, two distinct points. That was the case where we said it has two roots. We saw the second case where it was touching the graph at one point. In that case, we have one root, and then we have a case where it is not touching at all. In that case, we say the graph is having no real root, or the polynomial is having no real root. Therefore, when we started with, we said a quadratic polynomial can have at most two zeros. So this is what we conclude, that it can have either two distinct zeros, two equal zeros, or no zero. And this is exactly what it means when it says at most two zeros. So if ever asked how many zeros does a quadratic polynomial have, we do not answer as two zeros. We say a quadratic polynomial can have at most two zeros. I hope this is understood. So by now you have understood what kind of polynomial we'll study next. We'll be doing cubic polynomial. What is a cubic polynomial? So a polynomial with degree 3 is called a cubic polynomial. Let us see one example. In this polynomial, as the highest power of the variable is 3, its degree is 3, and therefore this is an example of cubic polynomial. Standard form of cubic polynomial is ax cube plus bx square plus cx plus d. Here x is our variable, a, b, c and d are real numbers, and also condition a must not be equal to 0. Why? Same reason. If a is 0, this entire term becomes 0. We are not having any degree 3 term, and therefore it is no longer a cubic polynomial. A cubic polynomial can have at most 3 zeros. Again, what does it mean? That it can have either 3 zeros, 2 zeros, 1 zero, or it can also have no zeros. Also, when a cubic polynomial is converted into graph by plotting its corresponding x and y values, its graph will intersect the x-axis at most 3 points. Now, there is no standard form of a graph for cubic polynomial, but a cubic polynomial graph may look like this. Now, as we can see in this graph is intersecting the x-axis at 3 points. So, this graph may represent a cubic polynomial. This understanding of the cubic polynomial can be extended to a polynomial of any degree n. This is a general understanding where a polynomial of degree n can have at most n zeros. And if a degree n polynomial is converted into a graph, it will intersect the x-axis at most n points. What do I mean by that? Consider an example of a polynomial. Now this is a polynomial and we can see the degree of this polynomial is 5. So if asked how many zeros this polynomial can have, it can have at most 5 zeros, and for the same polynomial, if I plot a graph, the graph will intersect the x-axis at most n points. So we note the number of points where a graph intersects the x-axis is the number of roots its corresponding polynomial will have. Now let us see some graphs and understand different number of zeros which are possible in these graphs. Now here what we see? Here we see the graph is intersecting the y-axis, but it is not intersecting the x-axis. And the number of zeros is dependent on the number of points where a graph intersects only the x-axis. So since this graph does not touch the x-axis, so the number of zeros or roots will be 0. So number of roots will be 0 in this case. Now here the graph is touching the x-axis at 1 point. So the number of roots are 1. Here 1, 2, 3. So the number of roots possible are 3. In this case, it's a quadratic polynomial parabola graph. I can see. So here the number of roots possible are 2. Let us see for this. 1, 2, 3, 4. Number of roots possible 4. 1. Here it is just touching. So only one root. Again, it is just touching one root. So 1, 2 and 3. So the number of roots possible are 3. Now, based on these examples, even you can address the first exercise of your chapter. Thanks for watching part 1. I know this was a lengthy part, but I have tried to cover all the necessary concepts of this chapter. The discussion of this chapter is again divided in 3 parts. We completed part 1 today, and using these concepts, we can solve the exercise 2.1. In the next video, that is part 2, we'll continue from here and we will discuss relationship between the zeros and the coefficients of a polynomial. In the last part, we will solve some additional practice questions. Hope you are understanding from the videos that we are creating. Thanks for watching. Do like the content, share it with your friends, share it specially with all the friends who are in grade 10, and subscribe so that you get the new notifications easily. Enjoy learning.